This is section 3.2, part 2. We are still looking to solve linear systems, and we are going to look at the elimination method here. And in this part, you're going to see 3 different examples using the elimination method. And the goal will be to eliminate a set of variables, either the x or the y. Your goal is to cancel them, eliminate them, get rid of them, however you want to say it. And in the first scenario, we're going to see that a situation in which we have the same coefficients. All right, the coefficients are going to be exactly the same. So our problem is 2x plus y equals 9, x plus y equals 4. And we want to look at the coefficients. And if you remember, the coefficients are the numbers in front of the variable. They're attached to the variable. So we can see on the y that both y's have the exact same coefficient. The coefficient of 1. There's like a little 1 in front of the y here, a little 1 in front of the y here. So when you have the exact same coefficients, meaning they have the same signs, to eliminate them, all you need to do is subtract these 2 equations. Alright, so I'm just going to simply subtract them. And 2x minus x simply gives me x. Y minus y cancels. 9 minus 4 gives me 5. Alright, so we see x equals 5. So, I'll make a little note here, as we did before. You're going to subtract the 2 equations. If the coefficients are the same. Okay, now I've got x equals 5. Before, we would plug x equals 5 into the equation we didn't use. Well, we kind of used them both here because we just subtracted one from the other. So you're going to have your choice. You're going to substitute, in this case, the value of x into either equation. Doesn't matter. Alright, so you get your choice. Do you want to put it in equation 1 or equation 2? So, I'm going to go ahead and use equation 2. We've got x plus y equals 4. And I'm going to substitute the value of x, which is 5, in for x. And solve for y. So subtract 5 from each side. 4 minus 5 gives me negative 1. So we see x equals 5, y equals negative 1. That would be your solution. So the solution in ordered pair form is 5, negative 1. Now, to make sure we have that correct, we need to check plugging 5, negative 1 into each of the original equations. So I've got 2x plus y. So now we're going to check. So I've got 2x plus y. That's a funny looking y. So 2x plus y equals 9. And then x plus y equals 4. So I'm going to plug in the value of x, which is 5, in for x, and the value of y, which is negative 1, in for y. Evaluate the left-hand side, so 2 times 5 is 10, plus negative 1, drop down the 9, 10 plus negative 1 is 9. So we see 9 equals 9, and that checked. Now the second equation, I'm going to plug in 5 for x, negative 1 for y, drop down the 4, 5 plus negative 1 is 4, 4 equals 4, and it checks. So we know we've done it correctly. So that was when you had the same coefficients. The next scenario is when you have opposite coefficients. Meaning you have the same number but opposite signs. And this is going to be problem number 2. 2 of 3. So we see negative x plus y equals 1. And then x plus y equals 1. When you have opposites, again, you want to cancel. Alright, so when you have opposites, in order to cancel, you're simply going to add the two equations together. Negative x plus positive x cancels, and y plus y is 2y, and 1 plus 1 is 1. So our rule here is you're going to add the two equations together. When the coefficients are opposites. And again, you get to plug the value of your variable into any equation. Alright, but we have, that's moving ahead. Plug the value of y in to either equation, just as we did previously. So we need to finish solving for y. So let me get back to here. So we said y plus y was 2y, and 1 plus 1 is 2. Lastly, divide both sides by 2, and we see y equals 1. So I'm going to plug the value of y, in this case 1, into either equation. So I'm going to use the first equation this time. Doesn't matter, you could use the second, and you should still get the same value of x. So I've got the opposite of x plus 1 equals 1. I'm going to subtract 1 from each side, and I get the opposite of x equals 0. Divide both sides by negative 1, x equals 0. So our solution is going to be 0, 1. And then we need to check that one. So again, we'll check. And the two original equations were negative, or the opposite of x plus y equals 1, and x plus y equals 1. So we see x is 0, y is 1, so the opposite of 0 plus 1 equals 1. Opposite of 0 is 0. Plus 1 equals 1, and we see 1 equals 1. Plug in 0 for here, 1 for y, and 0 plus 1 is 1, and 1 equals 1 on this side as well. So we can feel confident that 0, 1 is the solution we're looking for. Third scenario, dealing with your coefficients still. Your coefficients are now neither the same nor opposite. They're simply just different. So we'll work that. So we've got different coefficients. How do you cancel when the coefficients are neither the same nor opposites? So let's take a look at that. So problem 3. 3 of 3 here. So we've got x plus 5y equals 13. And we've got negative 4x minus 7y equals negative 13. So we can't add, can't subtract, because the y's won't cancel, and our goal is either to cancel the y's or the x, and neither of them will currently cancel. So what we need to do is make the coefficients either opposites or the same. If they're opposites, we will then add the equations together. If they're the same, we will subtract the equations from one from the other to cancel. But the first thing is to get the coefficients to be exactly the same. So I can see I've got a positive x and a negative 4x. So if I wanted them exactly the same, I would want this coefficient to become negative 4. If I wanted opposites, it would need to be positive 4. And you do that through multiplication. So you're going to multiply either one or both equations. Alright, sometimes it's one, sometimes it's both. In this case, it's just going to be one. So the coefficients are opposites or the same. Okay. So, what do I want to do? Alright, let's come on down here. I'm going to rewrite the problem real quick. So I've got x plus 5y equals 13. Negative 4x minus 7y equals negative 13. I want to get this coefficient to be positive 4. So I'm going to have to multiply this whole equation by 4. 4 times x gives me 4x. 4 times negative 5, or 4 times positive 5y gives me positive 20y. And 4 times 13 gives me positive 52. Since I've got positive 4x and this is negative 4x, I simply just have to slide this equation over, and I'm going to rewrite it so it's underneath the first equation, and it will be easy to add or subtract. So now, use our knowledge from the previous two problems. Since we have equations and the coefficients are opposites, should we add or should we subtract? And if you said add, you would be correct. Elimination method, same coefficients, you subtract. Ours are not the same, ours are opposites, so we add the two equations together. So let's add 4x plus negative 4x, they cancel. 20y plus negative 7y is going to give me 13y. And then 52 plus negative 13, what's that give us? That gives us 39. Now, just divide both sides by 13, and we see y equals 3. Y equals 3. So again, I can choose either of the two original equations, and I'm going to plug the value of y in. So I'll pick the first equation. I've got x plus 5 times 3 equals 13. Alright, 5 times 3 is 15, so x plus 15 equals 13. I'm going to subtract 15 from both sides, and we see x equals negative 2. So our solution in ordered pair form is going to be negative 2, comma 3. To make sure you're accurate, again, you would check. I've checked twice in this video, so I'm not going to check a third time, but you should always check. Alright, this is correct. So if you wanted to, you could check it and you would see it would work. Okay.